Hello everyone, I am Shinko Hayashi from Hosei University. In this work, we propose a random selection loop to improve deficient descriptions for 3D dense captioning based on point clouds. At the background, there are many deep neural networks for visual scene understanding with natural language processing, such as dense captioning, which generates sentences to describe how people or animals behave, or an event in the input image. However, images have a restricted field of view, which makes it difficult to grasp the physical size and locations of objects. In contrast, 3D dense captioning uses 3D scenes, which allows the actual size and location relation to be determined and described more accurately. The recent work, ScantoCap, adapts PointNet backbone and VoteNet to detect objects in 3D scenes, and introduces the relational graph module and a captioning module to address the issue that object relations are often ignored when describing detected objects. However, when generating or evaluating descriptions, they randomly select 40,000 points from the point cloud, which happens to generate deficient descriptions because some points may not be important. For example, the shelf is described as a lamp, and the table is detected as the stool under the table. To solve such a problem, we propose adding a random selection loop to improve the probability of obtaining high-quality points. We use the objectness score corresponding to the object to determine if descriptions are good or bad, then store the object information in the list. So random selection loop stores the bad object information in the bad list if the corresponding objectness score is less than 3, if it is 3 or more, stored in the good list. Then if previous information exists in the bad list, remove it. The goal is to repeat this process until all elements in the bad list are removed. In short, if there is no element in the bad list, end the loop and evaluate descriptions in the good list. But elements may not be reduced from a certain loop, we interrupt the loop after 3 loops. In this case, evaluate descriptions in the good and bad lists. And these conditions are not be satisfied, start the next loop with other random 40,000 points. We compare evaluation scores for all validation scenes on the ScanRefer dataset with ScantoCap. As we can see from the table, all results of our method have better than ScantoCap, but it is time-consuming. However, as we can see from these two figures, our method improves the descriptive deficiencies. For example, in ScantoCap the shelf and the table are misidentified as the lamp and the stool under the table respectively. But in this work, these objects are almost described the same as the ground truth. Thank you for your attention.